This is the fourth video installment in the North Carolina Final Exam Math 2 release test from released in 2014. This is video 4. Videos 1 through 3 have the numbers 1 through 14 on the exam. In the notes or the description for this video, you can find the links to the prior videos. So number 15 says segment FG has points F, 2, 4, and G, 6, 1. So I'm going to go ahead and graph those. Alright, so we have our segment of FG. Okay, if FG is dilated means that it's getting bigger or smaller, depending on what the factor of dilation is, with respect to the origin by a factor of k, to produce F prime G prime, which is our new image, which statement must be true? Okay, now, then you have several options. All right, and if you notice, A and B are talking about intersecting the y-axis, so it's asking about the, if you're looking at the equation y equals mx plus b, these two are going to be asking about b, which is the y-intercept. Okay, these two are asking about the slope, or the m. Okay, now, there are several ways to solve this. One way is to figure out what the slope and the y-intercept would be of your original down here, f and g, if it were extended, right? Okay, and then dilate it by, it says by a factor of k, so that kind of means of any constant. So we could dilate it by a factor of 2 and see what the new slope and the new y-intercept would be of our new line. Okay, or you could use a factor of 3, 4, whatever. You're basically just plugging in a number to see what changes. Okay, so we can try that. So first for the original line that we're given, f and g, if we look at the slope, right, rise over run, so rise 1, 2, 3, run negative 1, 2, 3, 4, negative 4. Okay, so our slope of our original line is negative 3 over 4. Okay, our y-intercept of our original line, we can go ahead and do a pretty good guess that it's 5.5 right here. And it does also look like it's 5.5 here as well. If you wanted to make sure, you could use the slope that you found and one of the points to figure out what the intercept would be by doing this. So you have your equation. Okay, use the slope that you're given, or that you just found, and also use one of the points. So for example, let's use point F. Point F was at 2, 4. And then you have your slope of negative 3 over 4. Okay, we know that our point x would be 2, y would be 4. So we can plug this into our equation. So 4 goes in for y. M is negative 3/4. X is 2. And then plus b. And now we can solve for b using that. So I'll move this over here. Okay, so 4 equals, and then we would have negative 6 over 4, which is going to be negative 1.5 plus b. We'd add 1.5 to both sides. And just like I suspected, b was 5.5. Okay? So to make room for everything, I'm going to go ahead and erase this. Okay, basically doing that, we found that m was negative 3 over 4 and b is 5.5 for the original one. Okay, now let's dilate it, both of those, by a factor of 2. And again, you could use any one to kind of guess and see what it would be. So for f, we originally started with 2, 4. If we were to dilate that by a factor of 2, when we dilate, all we do is multiply by that factor. So our first one, 2 times 2 would give us 4, and then 4 times 2 would give us 8. G, 6, 1. Okay, so G prime, again, we're just multiplying by a factor of 2, would give us 12, and then 2. Okay, so let's plot that new segment, f prime, g prime. Okay, so f prime would be at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. F prime. G prime would be at 12, too. So 6, 7, 8, 9, 10, 11, 12, 1, 2. All right, so now let's find, okay, so there's our segment. If we were to extend this line so that it would make a line like that, okay, let's figure out what the slope would be, okay? So our slope, we're going to go up 1, 2, 3, 4, 5, 6. To the left, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the slope of our new line is going to be negative 6 over 8, which does in fact reduce to negative 3/4. So guess what? The slope would be the same even after we dilated it. Okay, it would still be negative 3 over 4. Okay, our y-intercept, if you're looking, okay, is going to be pretty high up here, somewhere up here. And if you look at the options for the y-intercept, A says that it would be 5.5 plus our factor of k. Well, we use the factor of k of 2. So that would say that the y-intercept would be 7.5, which is somewhere around here. But the y-intercept is clearly way above that. So it can't be this first one. The second one says that the y-intercept would still be 5.5. That's not true. It's all the way up here. Okay, this one says that the line that passes through f prime and g prime has a slope of negative 3/4 times k, which is our factor. Technically, yes, it does, because negative 3/4 times 2 gives us this slope right here. But here's the thing. Slope always needs to be in the simplest form. Okay, this is not simplest form. Once you reduce it, this is simplest form. Okay, so the correct answer would be D. This one is a pretty tricky one, so you have to be pretty careful and read through. Just keep in mind that the slope, all right, the slope of a line is a proportion. And when you dilate something, the proportion is still going to be the same. Okay, so even if you didn't do this the long way and figured all this out, you could know that dilating something is not going to change the proportion. And here, slope is a proportion. All right, number 16. We have a triangle that's graphed, and it says it's going to be rotated 90 degrees counterclockwise. Okay, that's against the clock to the left, around the origin, and then it's going to be reflected or flipped across the y-axis. Which additional transformation will map the image triangle back onto the original triangle? So basically, we're going to do 3 things to it. Okay, the first one, we're going to rotate it 90 degrees counterclockwise. Then we're going to reflect it or flip it across the y-axis. And then finally, there's some sort of third thing that's going to happen. It's going to be one of these options down here. Okay, and that's going to make it end up back right where it started. Okay, so first, let's do the first one. Rotating it 90 degrees counterclockwise. Okay, if you memorize your rules for transformations, which you should if you haven't already, to rotate something 90 degrees counterclockwise, we're going to use this rule. We'll take our original xy coordinate, okay, and we have to change them, flip x and y, and then we're going to change the sign of y. Okay, so let's write down our original points. G is currently at 3, 6. F is at 2, negative 2. And E is at negative 5, 3. If I apply this transformation where I rotate it 90 degrees counterclockwise, I'm going to end up with some new points. Okay, G prime is going to be negative 6, 3. F prime is going to be 2, 2. E prime is going to be negative 3, negative 5. Okay, so now I'm going to go ahead and graph those. So here's G prime, F prime, and E prime right here. Okay, so we've done the first one. We've rotated it 90 degrees counterclockwise. All right, so next is to flip it across the y-axis. Okay, so if I'm flipping it across the y-axis, then what I'm going to do, this is my line of reflection right here. Okay, I'm going to count to that line of reflection and then see what that distance is and go use that same distance in the opposite direction. Okay, so for example, if I'm going to take G and flip it across the Y, I'm going to count how far away it is from my line of reflection. 1, 2, 3, 4, 5, 6. And then I'm going to count 6 in the opposite direction. 1, 2, 3, 4, 5, 6. And G double prime is right there. For F, F is 2 away from Y, so I'm going to count 2 in the opposite direction. Label that F double prime. And E is 3 away, so I'm going to go 3 in this direction. E triple prime, or no, sorry, double prime. Okay, and then I'm going to connect my triangle. All right, so far we have rotated it, and now we have flipped it. So now something else is going to happen. Okay, one of these options down here, that's going to get that green triangle to go back onto the original triangle. Okay, so let's go through. A says 270 degrees counterclockwise, so that's to the left, okay, around the origin. 270 degrees means that it's going to rotate 90 degrees 3 times, okay? And each time something rotates 90 degrees, it moves from one quadrant to another. So let's take one point, G prime, and let's see, if we rotate it 270 counterclockwise, then it would go, oops, then it's going to go here, 90, 180, and then 270, okay? If you look at G, right, we're trying to get G prime back here with G. That's not going to work out to bring it all the way around, so it can't be A. Okay, rotation of 180 degrees is going to bring G over here, 90, and then 180 over here. And that's not where we're trying to get it back to, right here. So it's not going to be that one. The next one is going to be reflection across the line y equals negative x. Okay, I'm going to draw that line for you. Y equals negative x would be this line right here. If I were to reflect it and take G prime right here and reflect it across this line, it would end up somewhere over here. That's not where I want it to be. So it's not going to be that one either. All right, what about reflection across the line y equals x? Okay, well that line is going to be right here. If I were to take G and reflect it across that line, right, count to the distance and then the opposite, it's going to end up right across that, okay, where it should be. Same thing with F. F is here, it's going to flip across that line to here. E is going to flip across the line to be there. Okay, so that is our correct answer, is D. All right, 17. Suppose that Jamal can choose to get home from work by taxi or by bus, okay? When he chooses to get home by taxi, he arrives home after 7 p.m. 8% of the time. When he chooses to get home by bus, he arrives home after 7 p.m. 15% of the time. Because the bus is cheaper, he uses the bus 60% of the time. What is the approximate probability that Jamal chose to get home from work by bus, given that he arrived home after 7 p.m.? So when I'm facing a lot of probability stuff and a lot of different information, the easiest thing to do is to draw a tree, okay, a probability tree. So we're going to start here with Jamal. Every day he faces a choice. He can ride a taxi or he can ride a bus home. Okay, now it says that he uses the bus 60% of the time. Okay, so that means 60% of the time he's on the bus. Okay, if he's on the bus 60% of the time, then that means that 40% of the time he's on the taxi. Okay, now it says when he chooses to get home by taxi, he arrives home after 7 p.m. 8% of the time. Okay, so if he takes a taxi, 8% of the time he gets home after 7 p.m. That means that when he takes the taxi, 92% of the time, he gets home before 7 p.m. If you're wondering how I got this number, I just took 100% and took 8 away. Okay, if he takes the bus, it says by bus, he arrives home after 7 p.m. 15% of the time. So I'm just filling in the rest of my chart. Okay, so it says 15% here, which would mean 85% here. Okay. So now I have my little tree diagram here, okay? So I'm going to look at the question that it's asking. This tree diagram just kind of organizes the information for me. So what is the approximate probability that he chose to get home from work by bus? Given, okay, that word given means I'm dealing with conditional probability. Given that he arrived home after 7 p.m. Okay, so basically what this question is asking is that out of all the times that he arrives home after 7 p.m., so out of all the times he gets home after 7 p.m., out of all those times, right, because it says given that he arrived home after 7 p.m., what's the probability that he got home by bus? Okay, so so this really is what we're asking. What's the probability that he got home after 7 p.m. on the bus out of all the times he gets home after 7 p.m.? Okay, so what we're going to do is we're going to find the probability that he gets home after 7 p.m. That's going to go in the denominator. And the numerator is going to be the probability that he gets home after 7 p.m. and he took the bus. Okay, so what we're interested in is right here. Oh wait, I'm sorry, no. Is right here after 7 p.m., right? And here after 7 p.m. Okay, so here's the thing. The probability that he takes a taxi and gets home after 7 p.m., we need to multiply these two, okay? So 40% times 8% is going to give us the probability that he took a taxi and got home after 7 p.m. Okay, we can't multiply percent, so we're going to put them into decimals and multiply them. Okay, we're also going to go here and multiply the probability he took the bus and got home after 7 p.m. Okay, up here, the probability that he took a taxi and got home after 7 p.m. was 0.032. For here, it's going to be 0.09. Okay, now let's go back to our little equation thing we set up over here. So out of all the times he gets home after 7 p.m., okay, and we just found out after 7 p.m. if he took a taxi, that's the chance of that. And after 7 p.m. if he took a bus, that's the chance of that. Okay, so that's out of all the times that he could get home after 7 p.m. And then we're looking specifically for the probability that he got home on a bus after 7 p.m. Okay, and that is 0.032. Okay, I know this is a little bit confusing, but conditional probability is one of the most difficult things to understand. So here, after 7 p.m. and the bus, that's up here, divided by all the opportunities of getting home at 7. Okay, so that's going to be 0.09 divided by 0.122. Okay, I just added the denominator there. And then that's going to be 0.737. All right, and the closest answer to that is D. All right, finally, number 18. A total of 540 customers who frequented an ice cream shop responded to a survey asking if they preferred chocolate or vanilla ice cream. 308 of the customers preferred chocolate ice cream. Okay, so let's stop there. If 308 preferred chocolate, that means that I can take the total number, 540, subtract the amount that liked chocolate, and that will give me the number of people that liked vanilla. Okay, 263 of the customers were female. So that means if I take the total, I subtract the females, I'm going to get the number of males. So I'm using the data that they gave me to get more information. 152 of the customers were males who preferred vanilla. So that means if I take all the males, which were 277, and I subtract out the males who liked vanilla, it's going to give me the males who liked chocolate. Okay. What's the probability that a customer chosen at random is male or, and remember in probability, or means to add, prefers vanilla ice cream? So I'm looking for the probability. I'm going to take all the males out of the total number of customers plus the people who prefer vanilla out of the total number of customers. Now here's the thing though, if I account for all the males and I account for all the people who like vanilla, some people are going to get counted twice. Okay, let's say that there is a man who also likes vanilla. He's going to get counted here with the men and he's going to get counted with the vanilla. And we can't count him twice because that will mess up our probability. So we're going to have to subtract out the males who like vanilla so that we don't count them twice. Okay, so all the males, let's see, we saw here that we have 277 males out of a total of 540 people. Plus, we found out that this many people like vanilla. 232 like vanilla out of the total, 540. And then subtract out the men who prefer vanilla. Okay? When we add, we keep the denominator the same, but the numerator is now, once we add up all those numbers, 357. Okay? Now, if you notice, this fraction is not over here, and that's because we have to simplify it. Okay? This fraction simplifies to 119 over 180, which we do find over there. Okay, so this is the end of the released 2014 North Carolina Math 2 final exam.